Hello, folks. This is homework number 7, carbohydrates and lipids. So make sure you set up your Cornell notes so you're ready to go. Okay, so your essential question for this video is, what are the important characteristics of carbohydrates and lipids? So I know we've been talking about this over the past few days, but this video is really going to kind of lay out all the details again for you and kind of bring back how these two are similar and how they're different. And so it's going to get you kind of thinking about that, which is what you're going to focus on class tomorrow. So this video will be really helpful to you in class. So keep in mind that you're going to want to write down as many details as you can. This topic of biomolecules is one that's really difficult for most students, and so if you're feeling confused, the best thing you can do is take as many notes as you can about what you're seeing and what you're hearing, and then talk to your teacher about it as well. So let's get started. Carbohydrates. Okay, we've talked about carbohydrates a lot this week, and we started off the week talking about monomers and polymers. And so carbohydrates have specific monomers and polymers. The name for a carbohydrate, the monomer, is a monosaccharide. Okay, a monosaccharide. Its examples are glucose and sucrose. So the glucose is probably going to be the one you hear most often, so make sure you take note of that one. And then the polymer for a carbohydrate is a polysaccharide. So kind of simple in that it uses the mono and the poly prefixes, which is nice. You just have to remember the saccharide ending, which just means sugar, which is convenient because we know carbohydrates do come in forms of sugar. So that's good. A couple of these examples for polysaccharides, we have starch, cellulose, and lactose. So starches we're going to find in a lot of our breads and our potatoes. Cellulose is actually, so this one right here, is actually what you hear in vegetables when you break them and you kind of get that crunching noise. That's cellulose. And then lactose is the milk sugar. So it's what you find in milk. And so if you've ever heard of someone saying that they're lactose intolerant, it means that they don't dissolve this carbohydrate right here. They can't break it down. So that's just kind of a tidbit to think about. Structure for carbohydrates, okay? We talked about that carbohydrate structure. They contain carbon, hydrogen, and oxygen. So you're going to see these written as C, H, and O, as you do over here, okay? These elements create a 1 to 2 to 1 ratio. So that means for every one carbon, okay, for every one carbon, you're going to have 2 hydrogens and 1 oxygen. And so you can look to this side example right here of glucose, okay? And you will see that if you count the C's, okay, which are actually at every corner right here, that might help, okay? If you count the C's, you will notice that there are 1, 2, 3, 4, 5, 6 C's. So if we look at our ratio of 1 to 2 to 1, that means our hydrogen, which is what the 2 stands for, should be 12. So we can count that. We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then that means our oxygen should be 6. It should be equal to whatever our carbon is, and in this case, it is 6. So keep those in mind as sometimes if you can't recognize something, it helps to count up the elements, especially for carbohydrates. So last thing under structure is that carbohydrates form a circular or rounded shape. I know that's not a perfect circle, but it gives that rounded shape when they bond together in most cases. The last thing is that function for carbohydrate. It is the quick energy source. So if you think about sugar rush, you get quick energy release because the sugar can break down quickly. And so the function of carbohydrates is that they serve as a quick energy source for us. Okay, so moving on to lipids. Again, we have a very specific monomer and polymer for our lipids. Our monomer is called fatty acids, and so that kind of is easy to remember in that we know our lipids are our fats. So if you can remember if lipids are the fats, oils, and waxes, then you can remember that the fatty acids is its monomer. For polymers, a lot of sciencey people will use the term triglyceride. You just really need to know the lipid term. I would recommend being able to recognize the triglycerides. So if you see it, don't think it's a protein or something like that. But the word lipid is really what you'll see most often. Remember that our lipids are found in our cell membranes. They create a lipid bilayer. So we have that right down here. Okay, so this red area put together is our lipid bilayer, and we have our protein molecules, our transport proteins and things like that embedded within the bilayer. But that's one of the most important functions of lipids in our bodies, so keep that in mind as well. Okay, so structure for a lipid. Just like carbohydrates, something to keep in mind, lipids contain carbon, hydrogen, and oxygen. They create these long chains that have many, many bonds, and that's really important for something we'll talk about in just a minute. So if you look up here at these two forms of lipids, okay, we have what we call a saturated fat and an unsaturated fat. Now, you might have heard of these things like at the grocery store or on television when they're advertising things like potato chips. They say no unsaturated fats or no saturated fats. The reason they talk about this is because the structure of these fats is different. So if you look at the unsaturated fat, you have something called a double bond in between two of the carbons. And that double bond just means that you're going to see it as two lines in between. And so if you notice, the saturated fat doesn't have that at all. So one of the ways I try to remember this, or I tell my students to remember, is that saturated equals single bonds. So saturated, single, okay? They don't have any double bonds in a saturated fat. Unsaturated has that little kink in it. It has a little bend to it is what that means. And it's because of that double bond. So that's something that you might see later on. So just keep in mind there's two different forms of lipids, is a saturated and unsaturated. So the last thing again is that function, is that lipid function. It serves as a long-term energy storage. So it's long-term energy. It's not broken down quickly, so the energy is there for a while. And one of the reasons it has so much energy is because of these bonds right here, okay? If you compare this image in the top right to the carbohydrate, there are way more bonds in these lipids, which are they represented by the lines in between the letters. There are way more bonds in the pictures of the lipids than there are in carbohydrates, and that's one of the reasons that these lipids can store so much more energy, because they have more bonding between their elements. Okay, so that was kind of just a quick wrap-up of the two biomolecules that we've talked about so far. So make sure that you review those things. And then the last thing that you need to do is write your summary. So at the bottom of your Cornell notes, you need to write a summary, okay, about 4 sentences long, describing 2 things. Okay, and if you want to break it down differently, you can, but I just give an example of how you could do this. In 2 sentences, you need to describe how carbohydrates and lipids are similar. And then in the next 2, you need to describe how carbohydrates and lipids are different. And I apologize for my typo there. It should be 2 space sentences. Anyway, so make sure that you write a total of 4 sentences, and if you decide to change how you do it, that's fine, but make sure you cover both how they're similar and how they're different. And again, this will definitely help you tomorrow in class. So if you need to, go back through, review this, and take down any more notes that you missed, or see your teacher in the morning.